Hey guys, I'm going to go over the line of best fit stuff that I was not here for. So you can check your work if you need to. So on the first one, the music, I do not, just FYI, I don't have a ruler. As I do this, it's going to be kind of annoying. So we simply want to make sure that we have roughly the same number of dots on each side of the line. That will give us a good idea of the line of best fit. That doesn't work out perfectly every time, but just use that as kind of a rule of thumb. If that trend continues, how many CDs were sold in 2006? So we'd be looking right about here. So roughly 650 million. I'm going to move this up so we get a little more space on there. So on this one, we have to graph those points. So 3 and 10,700, so just under 11,000. 6 and 11,700. 9 and 12,600. And I really don't know where these numbers are coming from because, quite honestly, I have 2 toddlers and the cost of raising them because of childcare is ridiculous. So I don't know. Maybe that'll go down when they get older, but somehow I doubt it. And then 12 and 15,000. That's an odd dot, sorry. And then 15 and 16,700. So those are pretty well lined up, although not perfectly. So if we look at the relationship that exists within the data, essentially, as our years increase, so does the cost of raising a child. So that's the positive linear relationship. So if we were to draw a line of best fit, which it doesn't ask us to, but if it were to, we would just draw that line, something like that. It's important to note that these lines don't continue in the same direction all the time. When we go beyond the data we have, so if we were to take any one of these and continue out, so like the music one, if we kept going, or here, if we kept going, the relationship is going to stop eventually. There's not going to be the same continuation of that relationship. Otherwise, if, when you're 30, obviously you're not a child anymore, but it's going to cost, $32,000 or something. I'm spitballing, so don't quote me on that. But generally speaking, those relationships only exist within those parts that we actually have. I think that's the worst I've ever explained that. I'm home with a sick kiddo today, so I'm also trying to figure out, he's also not napping well. So on number 3, as we graph those points, -2, +2, -2, 3, -1, 2, 0, 1, 1, 0, 1, 1, 1, -1, 2, -1, 2, -2, and 3, -2. So if we draw our line of best fit, and these will vary, whatever you have on yours is not necessarily wrong. It's just going to vary compared to mine. And hopefully be straight, because hopefully you used a ruler. So there's 2 parts that we're going to use to estimate these things. One is our y-intercept. Wrong one. This is our y-intercept right about there. So I'm going to call that y-intercept 1 because I'm just making an estimation. And then the other is our slope. So any points, if we're looking, this is roughly like down 1 over 1. So I would estimate this line of best fit to be y equals -x or -1x. You can write that either way, +1. And you can also put that in the point slope formula that we learned last class. Moving this up a little bit because I might need more space on that one. If I go ahead and plot these points, so first I need a scale. So my grade goes from a low of 60 to a high of 90. So we're going to start this at 60, 70, 80, okay, so 65, 70, 80, 90. So that'll work. Stick that 85, 75 in there. And then for my hours studied, we'll go ahead and start with 0, 1, 2, 3, 4, and 5. So if I graph those, I've got 3 hours, that was an 84. 2 hours, that was a 77. 5 hours was a 92. Oh, I didn't go quite high enough. 1 hour was a 70. 0 was a 60. 4 hours was a 90. And 3 hours was a 75. So if we, this is an excellent example of the trend not continuing beyond what we have, or not assuming that it would continue, because if we go out beyond 5 hours, if this trend were to continue, it would go up and up and up and up, and obviously if your test is going to have a maximum score, so that trend cannot continue beyond that point. Okay, so and I think I got ahead of myself. So I'm looking at a line. I'm going to go ahead and use that. 60. You'll notice that really not very many points, if any, are on the line. You're just trying to get that general idea. And this maybe needs to go a little bit higher because of the points on the top. But so if I estimate my line of best fit equation, I have a y-intercept of 60 and a slope, let's call that point one that I'm using. So I'll go up 20 and over 3. So I got to be careful about my scale. So my slope was the lovely 20 over 3. So for every 3 hours you spend studying, you can estimate a grade increase of 20 points. Obviously, again, that's up to a certain point. So I've got y equals 20 over 3 x plus 60. Predict the grade for a student who studied 6 hours. So I'd be looking at 6 hours, right about there. So we would estimate that they would have roughly 100%. I don't know if this is in percentages or not. For a final exam grade, 100. And then does this line go on forever? No, of course not, because there's going to be a maximum score. So now we're given the line of best fit. We can write the slope-intercept form of the equation shown in the scatter plot. This one I'm definitely going to move this up because I'm going to show you both the slope-intercept as well as the point slope. So first, slope-intercept, we got to find. I don't know when that stopped recording. So to come back up here, just review real quick. Found the slope. It's just difference between y over difference in x. 1.15 over 1, so a slope of 1.15. Over here, I put that slope in the A x minus h plus k. So I put in my 1.15 for slope, 2001 from this x up here, and 17.6 from this y. That's my hk. So now to put this into slope-intercept form, all I need to do is simplify it. So I've got 1.15x, I'm distributing here, 1.15 times 2001, one moment, so minus 2301.15, and then I'm going to drop down that plus 17.6. Combine that, so I've got negative 22.8, no, just kidding, 2283.55, and then I just drop down my y equals 1.15x. So that can be simplified into slope-intercept form, depending on how you prefer to do it. Okay, hopefully that didn't stop recording forever ago. So the disease one, the table shows the number of cases of foodborne, botulism in the United States for the years 2001 to 2005. Draw a scatter plot and determine the relationship, if any, exists in the data. So the year 2001, that's 39. It's right around there. 2002 is 28. 2003 is 20. 2004 is 16. That should be a little bit higher. 5 is 18. There does appear to be a relationship, but it does not appear to be super linear. So I'm going to go ahead and do a line because I don't have enough data to see what this looks like. This is just the statistics teacher and me being kind of cranky about it. This looks more like a curved relationship, but obviously the uptick that's happening, so it's coming down and then it's kind of going up just a little bit, but that's only 1 year that we have, so we don't have enough to say that's a curved relationship, but I also don't think we have enough to say it's a linear relationship. But for the purposes of this class, we'll make a very not straight line there. So slope-intercept form, move this up a little. So I need to figure out what points I'm using here, and this would help a lot if it were a straight line. I'm going to go ahead and use this point, and we'll call it this point. So we've got a slope of down 10 and over, well, that was dumb. Let's see, 2 years. So over 2 years. So negative 10 over 2, so a slope of negative 5. And we're going to go ahead and use this point right there, as our HK. So that is the point, this is silly, 2001.5 and 30. So come down here, do y equals negative 5, x minus 2001.5, and then my k plus 30. So, just checking my work here. If I simplify that, this is acceptable. Once again, this is the point slope formula. But if I distribute that, negative 5x. Math on that again. Negative 5 times 1.5, also negative. So that'll be a plus because it's a negative times a negative. 10,007.5 and then plus 30. So my slope-intercept form would be negative 5x plus 10,037.5. And that does not look right because if I look at this, my y-intercept should be somewhere at like 35. So I'm going to pause this and see if I can figure out what I did wrong. Okay, I see it now. And this is the reason. So because right here, this is starting at 2001 and jumping down to 0. So this would technically be the year 2000 instead of like 00. Then that's why the y-intercept is so very, very large, because this doesn't actually represent the y-axis. So that's why it's not going to land on 35, because if we go back 2,000 years, this would be our expected number of botulism cases, which is obviously not a trend we can trust. But so mathematically, everything was fine there. It was just the matter of thinking this was the y-axis when it's not. It's actually very far from it. And there should be a little squiggle in that to show that that is not. So that was just my problem in explaining it. So hopefully this was enough for you guys to kind of remember. Hopefully you've done this before. Maybe not, though. To get an idea for lines of best fit. Some practice was finding the equation, which we were working on last class, and then we're going to move next time into our piecewise functions. So thank you very much. Bye-bye.